Hello, my dear students and the rest of the learners. Welcome to this presentation in which I will be discussing on the topic Introduction to Computer Programming. This is part 2 of a two-part series of presentations in this topic. My name is Meme JM, or you can simply call me Emily Swap. In this presentation, I'm going to look at the common data types and the structures used in programming, the tools for designing program flow, or what we call the algorithm, the procedure for program design, program development lifecycle, the file handling and access method, and lastly, I'll look at program documentation. Let's commence by looking at the common data types and the structures used in programming. A data type is the nature of value to be taken by a memory location. It is what a computer operates on. This data type defines the operations that can be done on the data, the meaning of the data, and the way values of that type can be stored. The main classifications of data types are: number one, we have simple or primitive data types, whereby these are the data types that are provided for by the programming language with built-in support and are directly manipulated by the commands of the programming language. They include machine data types, the Boolean type, and the numeric types. What is machine data types? Or what are machine data types? All data in computers based on digital electronics is represented as bits, that is alternatives of 0 and 1 on the lowest level. The smallest addressable unit of data is usually a group of bits called a byte, usually an octet, which is 8 bits. The second type is Boolean type. The Boolean type represents the values true and false. Although only two values are possible, they are rarely implemented as a single binary digit for efficiency reasons. Many programming languages do not have an explicit Boolean type, instead interpreting, for instance, 0 as false and other values as true. The third type is the numeric types. These are data types that hold or represent numbers either that have fractional parts or are whole numbers. They include the integer data types, which are the data types that hold or represent numbers that have no decimal points. These numbers can hold negative or positive values. For example, 1, 12, 200, -2, -100, amongst the others. Number 2 is floating point or real data types. These represent or hold the values that have decimal points or fractional parts, but with a predefined limits on both their maximum values and their precision. An example is 1.0, 200.13, or 0.23. Number two, we have structured data types or data structures, or what we call the composite types. These are data types that are created by grouping the basic or simple data types together to form a new data type that can be operated on using a specific operation. The data structures are usually divided into two categories. These are, number one, the linear data structure, and number two, the nonlinear data structure. Linear data structure are the elements of a linear structure forming a sequence. Examples of linear data structures are arrays, linked lists, stacks, queues, trees, and strings. The second type are the nonlinear data structures. These are the elements of a nonlinear data structure that do not form a sequence. Examples of nonlinear data structures are trees and graphs. My dear students and the rest of the learners, trees are not classified or categorized under the linear data structure, but they are categorized under the nonlinear data structure. This is because their values or content or elements do not form a sequence, but it has branches. Therefore, the main data structures are, number one, array. They are also called vector, lists, or a sequence. They store a number of elements, but of the same type. The second are the records. They are also called the tuple or struct. This is a data type that is composed of both a mixture of real and integer types. The elements of records are usually called fields or members. Number three is union. This is a data type that is defined to contain only one type of primitive data types. For example, only float types or only integer types. Number four is a set. A set is an abstract data structure that can store certain values without any particular order and no repeated values. Number five is an object. It contains a number of data fields like a record and also a number of subroutines for accessing or modifying them that we call methods. Number six are the string and the text types. These hold or store sequences of characters from a character set. Number seven are a linked list. They are also called lists. It is a linear collection of data elements of any type called nodes, where each node has itself a value and points to the next node in the linked list. Let's now look at non-composite types. These ones are also called the user-defined types. These are data types that are created by the programmer or user by combining multiple elements of other types and defining the valid operations of the new data type. They include, number one, pointers and references. Number two are enumerated lists. Pointers and references are data types where the value refers directly, or a value refers directly to another value that is stored elsewhere in the computer memory using its address. In other words, pointers and references are data types whose value refers directly to another value that is stored elsewhere within the computer memory with the use of its address. Number two is enumerations. It contains distinct values which can be compared and assigned, but which do not necessarily have any particular concrete representation in the computer's memory. Compilers and interpreters can represent them arbitrarily. Let's now look at the tools for designing program flow or algorithm. Program design tools are the tools that are used to depict an algorithm. An algorithm is the series of steps or a procedure that is followed in execution of a program. The tools used to illustrate the flow of execution of a program include pseudocones, flowcharts, the structure charts, decision trees, decision tables, amongst others. Let's look at the pseudocode. This is a way of describing an algorithm in form of brief, simple English-like statements. The following is an example to demonstrate how to write a pseudocode. My pseudocode, my dear students, and the rest of the learners, indicate the flow of a program that can be used to calculate the area and perimeter of a circle. When you are writing a pseudocode, it's always important that to start with the title for your algorithm. The title for my algorithm in this case is calculating area and perimeter of a circle. The first statement is set a constant memory location aside called pi and assign it 3.43. Number two, set assigned variable memory locations called radius r, perimeter p, and area a. Number three, start. Number four, request the user to enter value of radius. Number five, store the value entered in memory location called radius. Number six, set perimeter as 2 times pi times radius. Number seven, set the area to pi times radius times radius. Number 8 is display the perimeter. Number 9, display the area. And number 10, stop. My dear students and the rest of the learners, kindly note that pseudocode is simply a set of statements that indicate exactly what a program is going to do. And those statements will be executed in the order that they are written. In other words, an algorithm are simply English-like statements that indicate the flow of how the program will be executed. So this is a pseudocode for an intended program for calculating the area and perimeter of a circle. Let's now look at flowcharts. A flowchart is a graphical tool used to describe the program execution logic, sequence or flow of data, processing operations or activities through a particular computer program with the use of both simple statements and special symbols with special meaning. In other words, my dear students and the rest of the learners, is that a flowchart is a pictorial or diagrammatic representation of an algorithm, or a diagrammatic or a pictorial representation of a program flow. They are used by programmers in two main ways. Number one, they are used to plan the structure of a program before it is written. Number two, they are used by programmers to describe the structure of a program after it has been written. Some common symbols used to draw program flowcharts are: number one is an ellipse, also called terminator. It denotes the beginning and the end of the program algorithm. Number two is a parallelogram. It is used to denote an input or output operation. For example, read, print, or write. For example, read the radius, print area, write area. Number three is a rectangle, which indicates that a processing activity or data transformation is taking place. Simply, it is used to illustrate an operation. For example, add A to B and assign the results to a memory location called sum. In other words, sum is equals to A plus B. Number four is robust. It is used to specify a condition. It's a diamond shape that shows where a decision or test is to be made between two alternatives. My dear students and the rest of the learners, I'm going to demonstrate how we use each of these symbols using an example. Number five is a connector. It is used as a connecting point or interface for arrows coming from different directions. And the last one is an arrow, which is used to indicate the direction of flow or program logic. The following is therefore an example of a flowchart for a program that accepts a radius for a circle and then calculates the area if the radius is greater than 5 centimeters, or a perimeter if it's less than 5. Then it displays either the area of or a perimeter based on the radius that has been entered. So, just as I have said, always begin drawing your flowchart from top. That is, from begin. You can call it start. So, this is the symbol that we use, just as I have said, to indicate either the beginning or the end of an algorithm. And then we use the arrow to indicate the flow. Assign 3.143 to a memory location called the pi. In other words, this operation or this statement indicates or states that create a memory location assigned called pi and initialize it with the value 3.143. And then once that is done, the program will prompt the user for a radius, and therefore it reads input radius. From there, we check whether the value entered as radius is greater than 5 or not. So this is the conditional symbol that we have called a rhombus. If the radius entered is greater than 5, then perform the operation. Multiply the content of memory or variable called pi or constant. The constant value called pi. In other words, this is how we did this statement, my dear students and the rest of the learners. This operation means or reads as follows. Pick the content of the memory location called pi. Multiply that value with the value entered as radius, and then multiply again with that same radius, and the results, assign them to the memory location called area. In other words, to get area, we multiply, or the program will have, or the compiler, or the CPU will have to multiply pi times radius times radius. And then from there, output area or display area, and then we end the operation or the execution of the program. What about if the radius that has been entered is less than 5? If it is true, or if the value of radius is not greater than 5, if the value of radius is not greater than 5, then compute perimeter by multiplying 2 times the content of pi times the content of radius, or what has been entered as radius. And then display the perimeter or output perimeter and end the operation. So in this case, my dear students and the rest of the learners, the area will be computed if the radius entered is greater than 5. But the perimeter will be computed if the radius that has been entered is not greater than 5, meaning it is false. In other words, is radius greater than 5? No. If not, the program is expected to compute the perimeter of the circle and display the perimeter and then terminate the program. And therefore, we end with the end. So as you can see, my dear students and the rest of the learners, in this program or in this flowchart, I have integrated all the symbols for a flowchart. One in this case, which has begin and end. The second one is the one which is for pi, area, and perimeter. The other one is the one with the condition, radius greater than 5, true or false. And then we have 3 symbols, one for input radius, the other one for output radius, and the other one for output area that are performing the same task. Number 3, or the other way of developing algorithm, is use of structure charts. These are tools used mainly to show relationships between program modules and graphically depicts the breakdown of modules. It is often used with other design tools such as pseudocodes and flowcharts to express the process or procedure logic. The following is an example of the design of exam results using a structure chart. In this structure, my dear students and the rest of the learners, you can see that I have the main function, which is on top, which I am calling the overall function. And then below it, we have the input details function, the process details function, and the print report function. These ones are called major functions. And then the major functions can be further broken down into sub-functions. For example, the input details major function has been broken down further to the sub-functions for validating input and editing input. Then the process details major function is broken down into calculate subject total, calculate student mean score, calculate mean grade, and calculate comment sub-functions. While we have the print report major function being broken down further to a sub-function for printing total, marks, mean score, mean grade, and the comment. In addition, the sub-functions can further be split or broken down. Like in this case, I have validate input broken down to a sub-function called print errors. So by the look of this structure, we can be able to see how the program has been broken down into various modules from the main module or main program all the way to the lowest module. Number 4 is use of data flow diagrams or DFDs. A data flow diagram is a diagrammatic representation of the flow of data through a process or a system or a subsystem or sub-process. It shows what happens to the data as it goes through a process. Like a flow chart, a DFD also uses standard symbols and notations. Some of these symbols include, number 1, we have a data flow symbol, which is an arrow. And then we have this other symbol that is used to indicate process. Number 3, we have this symbol that is used to indicate the source or destination. The source or destination. Lastly, we have this symbol which indicates data store. So those are the main symbols or some of the symbols that are used in DFDs. Let's now look at the procedure for program design. This is the actual development of the program's processing or problem-solving logic that is called the algorithm, which enables the programmer to come up with the models of the expected program. The models show the flow of events and data throughout the entire program from the time the data is input to the time the program gives out the expected information. Therefore, program design involves developing the method of solving the problem by planning and creating a solution using structured programming techniques such as top-down program design, the pseudocode, flowcharts, control structures, decision tables, and decision trees. In program design, the programmer identifies the processing tasks required and the precise order in which they are to be carried out. That is an algorithm from which the computer program will be produced. We have number one, data structures. Or the first step is to design data structures. This defines the format, or this is defining the format and type of data the program will use. The second step is to design the user interface, which is the design of the screen that the user is going to see and use to enter data or display data. Number three is to define the kind of data to enter into the program, that is inputs. Then number four is designing the outputs, which is the possible data displayed from the screen. Number five is designing the algorithms or coming up on developing the algorithms. That is the methods of calculating outputs depending on the inputs. So there are three overall fundamental steps for designing a program. These are, number one is to define the output and data flows. Before beginning a program, you must have a firm idea of what the program should produce and what data is needed to produce that output. A programmer must know what the output is going to be before he or she writes the program. Anything that the program produces and the user sees is considered as output, which you must define in advance. You must know what every screen in the program should look like and what will be on every page of every printed report. The output definition gives you insight into what data elements the program should track, compute, and produce. Defining the output also helps you gather all the input you need to produce the output. Number two is to develop the logic. After you and the user have agreed on the goals and output of the program, the rest is left to you as a programmer. And therefore, your job is to take that output definition and decide how to make a computer produce the output. You have taken the overall problem and broken it down into detailed instructions that the computer can carry out. This doesn't mean that you are ready to write the program. No, it is quite the contrary. You are just ready to develop the logic that produces that output. The output definition goes a long way towards describing what the program is supposed to do. Now, you must decide how to accomplish the job. You must order the details that you have so that they operate in a time-ordered fashion. You must also decide which decisions your program must make and the actions produced by each of those decisions. Therefore, in this step, you decide the algorithm for the program either in the form of pseudocode or using pictorial representations such as flowcharts or any other tool that you may decide to adopt. The third step is to write the code. At this step, you now translate the design into a set of instructions that can be understood and be executed by the computer with the use of a programming language. Let's now look at what we call a program development life cycle, or PDLC. Generally, every program is developed through a set of stages that are called a program development life cycle. So you don't just wake up and then you come up with a program and then you just code it. And you think that that program will solve the problem. No, you have to go through a number of stages or follow a certain set of steps in order to be able to come up with a program that can solve the existing problem. A program development lifecycle is a recommended series of steps that are supposed to be followed when developing a program. Therefore, before committing yourself in writing a program, the following are the set of steps that must be followed or that you must follow, and they form what we call the program development lifecycle, or PDLC. The first step is problem recognition. The second one is problem definition. The third one is program design. Number 4 is program coding. Number 5 is program testing and debugging. Number 6 is program implementation and maintenance. And number 7 is, of course, review, which we usually place under program implementation and maintenance. In other words, my dear students and the rest of the learners, is that we can break down step 6 into 2, whereby program implementation can be treated as number 6, while program maintenance and review can be step number 7. The following is therefore a diagram illustrating the program development life cycle. The first one is problem recognition. And of course, in every step, you also do the documentation for that stage. And therefore, program documentation is not a single step, or it's not supposed to be done at just a single step, but it's supposed to be done at each and every step. Number 2 is problem definition, of course, together with its documentation. Number 3 is program design, together with its documentation. The fourth step is program coding, together with its documentation. Number 5 is program testing and debugging, accompanied by its documentation. Then number 6 is program implementation and maintenance, which also goes with its documentation. My dear students and the rest of the learners, we call this diagram or this set of stages as a cycle because after a program has been implemented, during maintenance, one may realize that there's a problem that has not been sorted, or the initial problem has advanced and there is a new type of problem that is existing and that cannot be solved by the current program as it is, and therefore the programmer has to then proceed again to the first step, which is problem recognition. And that makes P, D, and C to be referred to as a life cycle. In other words, that's the reason as to why we refer to the stages or steps of program development as a cycle. Therefore, in order to develop a program that can adequately solve the problem at hand, a programmer has to do the following. Number one is specify the problem requirements. Number two is to analyze the problem. Number three is to design the algorithm to solve the problem. Number four is to implement the algorithm. Then number five is to test and verify the completed program. Number six is to maintain and update the program. My dear students and the rest of the learners, if you want to get detailed coverage of program development and explanations of the exact information or the exact activities that are supposed to take place at each of these steps or at each of these stages, I kindly advise that you visit EmilySwap ICT YouTube channel and go through a series of presentations or videos by the title Elementary Programming Principles. Elementary Programming Principles. In that series of presentations or videos, I have explained in depth most of the content in relation to the program development life cycle, amongst others. Let's now look at file handling and access methods. Files are storage locations in which data is stored external to the main memory for future reference and modification. So, the information is maintained external to the program environment in the form of files. The main file handling activities or operations include reading from the file, writing into the file, adding data into the file, creating a file, deleting a file, modifying a file, copying a file, amongst other activities. Let's look at classification of files. How do we classify files? In programming, files can be classified in three main ways, which are, number one, according to the way records are accessed. And in this case, the main types of files include sequential files and random access files. The sequential files are those files in which records are arranged in sequence in the order in which they are written to the file and can only be accessed in serial order or sequentially. A sequential file consists of a list of records of the same data type, which is specified in the declaration of the file. The number of records that a file may contain need not be specified when the file is declared. However, only one component or one record of a file is directly accessible at a time. Number two are the random access files. These are files which are stored in such a manner that its content can be read directly without passing through the intervening records. The second way of categorizing our files is according to the way the data is stored in the file. The main types of files in this category include the text files and binary files. The text files are those files in which data is stored in form of ASCII codes, irrespective of the data type, and are manipulated by a text editor. They are mostly used as program files and report files. Number two are the binary files. These are files in which data is stored in the same way as it is stored in memory, irrespective of the data type. The data is stored in binary format. The way the file is opened for processing determines whether a file is a text file or a binary file. The third way of categorizing files is according to the mode of use, whereby the main types of files in this category include the input files, output files, and those files which serve both as input and output file. In other words, input, output files play the roles from both input files and those which are carried out with the use of output files. So what are input files? Input files are files that can only be read from by a program. The output files are those files that have been written by the program. That is, the program that created that file. Number three, we have the input-output files, which, just as I have said, are the files that can both be read from and written into by the program. So how is the content organized in files, and how is it organized? So let's look at file organization and access. The mode of opening a particular file determines how various details of the file are handled. File organization, therefore, refers to the way in which files are physically arranged on a storage device. Further, there may be a single key or multiple keys associated with the file. The main factors that influence the choice of particular file organization for given applications are: number one, the economy of storage. Number two is convenience of updates. Number three is the ease of retrieval. Number four is reliability. Number five is security. Number six is integrity. Therefore, based on its physical storage and the keys used to access records, files can be classified as sequential, relative, or random, and index sequential files. So the three main file organization methods are sequential, random, and indexed sequential. So what is sequential file organization? This is a method or a way in which records are written one after the other within the file in order. When the file is created and can be accessed only in the same order in which they are written when the file is used for input. In other words, the records within sequential files are written one after the other in their order when the file is created, and they are accessed in the same order. Number two, we have relative or random file organization. This provides an effective way to access individual records directly. In a relative file organization, there is a predictable relationship between the key and the record's location in the file. When a relative file is established, the relationship that will be used to translate between the key value and the physical address is designated. When a record is to be written into a relative file, the mapping function is used to translate the record's key to an address which indicates where the record is to be stored. When the record for a particular key is to be retrieved, the mapping function is applied to that key value, translating it to the address where the record can be found. Thus, the predictable relationship between records key values and records storage locations is used both when a record is stored and when it is received. Number three is the indexed sequential file organization. This is an effective way of organizing records when there is need, both to access the content sequentially by some key value and also to access the records individually by some key. An indexed sequential file combines the access types that are supported by a sequential file as well as a relative file. An index is used to service a request for access to a particular record, and the sequential data file alone is used to support sequential access to the entire collection of records. Let's now look at the program documentation. A program documentation is the writing of support materials explaining how the program can be used by users, installed by operators, or modified by the programmers. Documentation is also a document showing what a program does and it can work under what conditions. It's a written explanation of how the program works and how to use that program. All the stages of a program development should be documented in order to help during future modification of the program, and they should be done at each stage before progressing to the next stage, just as I've already said in this presentation. Therefore, documentation is an integral part of the inspection process. It ensures that the intentions of the originator of the system survive from specification to design and from design to coding. The three targets of documentation are the users, the operators, and the programmers. A complete program documentation should possess the following. Number one is program specification, which indicates the problem definition, the inputs, the files, as well as the outputs. Number two is program design tools, which includes flowchart, pseudocode, decision trees, amongst others. Number three is program listing, which includes the test data, test results, users notes, operators manual, summary, and conclusion. So the main functions of documentation are: number one, it helps you maintain the system. Number two, if you want to do some changes or make modifications, you can just know where those modifications can be. Number three, it's easy to update the program. So the advantages of program documentation are, number one, it's easy to know the purpose of each part of the program. Number two, it's easy to know the process of the program and the others can follow the documentation or the program. Number three, it consists of written descriptions and procedures about the program, therefore enabling the user to know how to use it. Number four, it's easy to know under what condition the program works. Number five, it helps one maintain the system. Number six, if you want to do some changes, you can know where those changes can be. Number seven, it's easy to upgrade the system to solve the arising needs. Number eight, it helps the user to work with the software with minimal or minimum guidance. So what are the main methods of writing documentation? The two main methods of writing documentation are internal documentation, and number two is external documentation. The internal documentation entails the methods used when coding a program in order to make it readable and help other programmers to understand the code statements. This includes indentation and spacing, which help to easily identify the sections of the code in a program. Number two is use of comments. These are the explanatory, non-executable remarks that are written within the source program to help the programmers understand the code statements or what a section of the code does. Number three are suitable variable names. The names used should be associated with what is being stored so that further explanation is not needed. In other words, when you are coding a program, it's always advisable that you give or use variable names whose you can easily tell what they contain or what they entail just by their name. Number two is external documentation. These are the reference materials such as user manuals and tutorials that are printed either as booklets or recorded in storage mediums in soft copy. The documentation for a simple program generally falls into four sections, which are identification, general specification, user information, and the program specification. These are always included in the documentation for a program. Identification should include the title of the program, short statements of its function, the author, date written, the language used and the version where relevant, and the hardware requirements. On the general specification, we include a description of the main actions of the program under normal circumstances, file specifications, restrictions and or limitations of the program, and references to any text explaining any complex procedures or techniques that have been used in the program. Under the user information, we include the format of input required. For example, source documents, how to produce outputs and their layout, and detailed instructions on how to run the program. Under the program specification, we indicate the design of the program using structure charts or flow charts, annotated diagrams listing, and testing procedures, including test data and expected output. So, the types of documentation are: number one, user documents or user-oriented documentation. Number two is operator-oriented documentation. Number three are the technical documentation, which is also called programmer-oriented documentation. What is user-oriented documentation? This is documentation which is written to explain to the user how to use the program, thus enabling him or her to be able to learn how to use the program as quickly as possible and with little help from the programmer. It is written in plain English and not in the technical programming language of technical documentation. It includes the hardware requirements, how to install the program, how to run the program, how to enter data, what the output looks like, how to use any menus, special features of the program, error messages, and advice on how to correct them when they occur. That is how to troubleshoot any errors. On the side of operator-oriented documentation, it is a documentation that helps computer operators to be able to install and maintain the program. It is meant for computer operators, for example, technicians. The third type of documentation is programmer-oriented documentation, which is also called technical documentation. It is written for skilled programmers. It provides necessary technical information that can be used to help programmers in future modification of the program. In this type of documentation, all stages of the program development should be documented because, number one, there may come a time when a need arises to revise or modify the program. Number two, other programmers may think of ways of improving your program. Therefore, technical documentation is a documentation that is used by programmers to be able to know what each section of the program does and how it works, so as to be able to maintain the program, know which part needs to be modified, and be able to update the program. Some of the reasons of technical documentation include: number one, the programmer needs to understand what was written a few weeks or even months before when writing a long program. Number two, extremely large programs are written in teams where certain teams write particular sections of the program code. Each team, therefore, needs to understand what the other teams have written so that the whole thing can fit together. Number three is to help a new programmer to be able to read and understand the written program so as to help him or her to revise it to fit a new situation, modify it, or correct it for logical error that may have shown up after using extreme data. So, technical documentation should include, number one, the problem that the program is intended to solve. That is the purpose of the program. Number 2, the algorithm. Number 3 is the program code or listing with its internal documentation. Number 4 is test data and results produced by the program. Number 5 is data and file structures. Number 6 is structure and flow diagrams, which show the relationships between the program modules. So, how do you prepare a simple program documentation? The procedure for preparing a documentation for technical users is: number 1, determine what information needs to be included. Number 2, decide how much of the documentation should be within the program code and how much should be separate from it. Number 3, choose the appropriate documentation tool. The procedure for preparing software documentation for end users, on the other hand, is: number 1, determine the business reasons for your documentation. Number 2, understand the audience that you are writing the documentation for. Number 3 is to determine the appropriate format or formats for the documentation. Number 4 is to decide what form or forms the documentation should take. Number 5 is to choose the appropriate documentation tool. And with that, my dear students and the rest of the learners, we have come to the end of this presentation and the end of the topic on Introduction to Computer Programming. Congratulations for learning part 2 of 2 in Introduction to Computer Programming topic. You can access part 1 of the topic as well as other computer or ICT videos by clicking or tapping on Emily Swap ICT YouTube channel below this video. You can also visit Emily Swap Life Skills YouTube channel for free life skills, motivational, and inspirational resources. To subscribe to this channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emilyswap@gmail.com. Thank you very much for listening to me, and God bless.